When you're trying to wrap your head around something new, maybe a tricky concept or a complicated diagram,
Mm,
have you ever noticed if your hands kind of instinctively get involved? Maybe you point at stuff or trace lines.
yeah, definitely.
It makes you wonder, right? Is that just a habit or is there actually something about using our hands that helps us learn better?
Well, that's exactly what we're digging into today.
Oh, good.
We're going to explore this surprising connection between using your hands and how effectively you actually learn. And it's not just theory. We've got some really fascinating research right here that shines some light on it.
Exactly. We've got this really interesting study. It's from educational psychology called How Learners Use Their Hands for Learning, an eye tracking study.
Right.
What grabbed me about this one is it didn't just ask if using hands helps, but it specifically looked at how pointing and tracing might affect how well we understand new information, different actions.
Yeah, the specifics matter. So the mission for this deep dive really is to get to the bottom of this for you. Does physically engaging with the material pointing, tracing, does it actually make learning more effective?
What does the science say? Is it just something we do, or is there a real cognitive advantage there?
Exactly. Let's find out.
Okay, so let's start by thinking about how we usually learn. We read, we listen, we watch. The focus is so often on, well, eyes and ears.
The classic senses for learning.
But what about touch? It feels like our haptic senses, that's kinesthetic, the movement sense, and tactile, the actual touch, they often get kind of sidelined in these discussions.
You've hit on a really important point there. While visual and auditory learning are, super well studied, there's this growing idea that these haptic senses might be way more important than we've traditionally thought.
Right.
It's not just about passively feeling something, it's about actively involving your body in taking in that information.
And that brings us to something crucial that came up in the research right away, the difference between tracing and gesture.
Ah, yes, that's key.
Because when we talk about using hands, you might think of like gesturing while talking, but tracing in this context, it's different. It's more focused, like moving your finger along a surface. It's an interaction with the thing you're learning about.
Exactly. Not just waving your hands in the air while you talk. Gestures often go with language, right? But tracing is a more direct way of engaging with the actual material itself.
Okay.
And it turns out there's quite a bit of research looking at what happens when we trace things while we learn. They even call it the tracing effect.
The tracing effect. Okay, so this isn't a brand new idea then. What have researchers found about this in the past?
Oh, absolutely not new.
Yeah.
The study we're focusing on builds on a really solid base.
Yeah.
Um, for instance, back in 2014, Mackin and Jins found university students learning about the heart.
The heart. Okay.
Yeah, they actually learned it better if they were encouraged to point and trace the parts on a diagram.
Mhm.
So it was an early sign that this kind of hands-on thing could be really useful.
And not just for uni students, right? I saw something about younger kids too.
Yeah, exactly. Here and colleagues did some fascinating work with like 11 and 12-year-olds. Geometry,
Geometry, tricky subject.
definitely. And they found that tracing the geometry problems actually improved how well the kids could solve them later.
Yeah.
And what was really interesting was this kind of gradient effect they saw.
A gradient. What do you mean?
Well, students who physically traced on the paper did better than those who just traced in the air, miming it.
Ah, okay.
And both of those groups did better than the kids who didn't trace at all.
Wow. So the actual physical touch seemed to add something extra.
It really suggested that, yeah.
Mm.
And Jins and his team followed up, looking at geometry again, but also things like the order of operations in math. Same deal. Tracing worked examples on paper led to better scores on tests where they had to apply the knowledge. Transfer tests, they call them.
And it works on screens too, not just paper. I think I saw a study about iPads.
You did. Agostino and her team, 2015.
Yeah.
Younger kids again, primary school, learning about temperature graphs on iPads. Tracing the graphs with their fingers helped them understand it better. And they link this to this idea of biologically primary knowledge.
Biologically primary knowledge. What's that about?
It's the idea that we have this fundamental, almost built-in understanding from physical actions, like moving things, touching things. Tracing might tap into that basic knowledge when we're trying to learn something new and maybe more abstract, which they call biologically secondary.
Huh. Connecting the new stuff to our basic physical understanding, that makes a lot of sense.
It's a recurring theme,
Yeah.
and the research kept going. Tang and others in 2019, Wang more recently in 2022, They looked at tracing for things like the water cycle, more
With
geometry.
different subjects again.
Yeah. And they found tracing, sometimes even this thing called imagination tracing, where they traced with eyes closed to visualize.
Whoa, imagination tracing.
Yeah, it helps students and young adults remember info, apply it better, and sometimes it even made the learning feel less overwhelming, reduced cognitive load.
And not just for kids or abstract stuff. I remember seeing Jins and King looked at university students learning astronomy on a computer.
That's right, 2021. Pointing and tracing helped them remember, apply the knowledge, and interestingly, it also boosted their motivation and lowered that feeling of being overloaded.
So better learning and felt better doing it?
Pretty much. But then you start seeing some nuances. Uh, Yeo and Tseng in 2019 found tracing seemed really helpful when the material was super visual and spatial.
Like diagrams and maps?
Exactly. But maybe not so much for stuff that wasn't as visually based. So the type of material you're learning seems to matter.
Okay, that's an important caveat. And then there was that eye tracking study before this main one we're looking at, Korbach.
Yes, Korbach and colleagues in 2020. They used eye tracking, looking at students pointing and tracing the heart on a touchscreen. And again, it improved learning performance and helped focus their visual attention.
So across the board, different ages, paper, digital, different subjects, there's this consistent finding that using your hands, particularly tracing or pointing, seems to help.
It's pretty striking, isn't it? It really points to something fundamental going on there.
Okay, so we've seen the evidence that it can help. But the big question for you, the listener, has to be, why? Why does this work? What are the theories behind this tracing effect?
Right. This is where it gets really interesting theoretically. Researchers have a few main ideas floating around. One key one we touched on is biologically primary knowledge.
Right, tapping into basic physical skills.
Exactly. The idea is that tracing connects to these skills we learned really early on just by interacting with the world physically. Babies exploring everything with their hands. So tracing might make it easier to grasp new, more abstract stuff, the biologically secondary knowledge, by linking it back to these really ingrained motor pathways.
Okay, that feels intuitive, like leveraging an existing system in the brain. What else?
Another big one is cognitive load reduction. Cognitive load is basically your mental bandwidth, right?
Yeah, how much effort you're putting in.
Yeah. And there are two types. Intrinsic load, just how hard the material itself is, and extraneous load effort caused by how it's presented, like confusing instructions or a bad layout.
Got it.
So the theory is that tracing might help you focus your attention, cutting down on that extraneous load, making learning more efficient. Or maybe it helps you process the core material more deeply, which relates more to intrinsic load. But it's worth noting, not every study actually found this load reduction.
Ah, so it's not a definite thing that tracing always makes it feel easier?
Not necessarily guaranteed, no. Which leads to another idea, the attention directing function.
Okay, what's that?
This one seems pretty straightforward. The simple act of pointing or tracing might just physically guide your eyes to the most important parts of what you're learning.
Like shining a spotlight.
Exactly. Helping you connect the dots maybe between text and a diagram. There's even this thing in basic cognitive research called the near hand effect.
Near hand effect.
Yeah, basically, things near your hands tend to get prioritized by your visual system. If your hand is resting near something on a page, you're more likely to look there. So your hand acts like an anchor for your attention.
Huh. So your hand literally becomes a guide for your eyes, keeping your focus locked in. That makes a lot of sense. Any other theories?
One more main one, the multimodal memory model.
Multimodal. Sounds complex.
It just means multiple modes, multiple types of memory. This model suggests that when you do an action, like tracing, your brain doesn't just store the visual or verbal info, it also creates a motor memory of the action itself.
Ah, memory of the movement.
Precisely. And having that extra motor memory trace can make it easier to recall the information later. This model predicts it should especially help with remembering things directly linked to the action, like the names of parts you physically traced.
Okay, so we've got a few possibilities. Connecting to basic skills, reducing mental load, guiding attention, or creating extra motor memories. Now let's get into the specifics of this new study, the Park et al. One that really pitted pointing against tracing. What was the setup?
Right, so this study was designed very carefully to compare pointing and tracing head-to-head. They had 3 groups of university students.
Okay.
Group 1, instructed to use pointing while learning. Group 2, instructed to use tracing. And Group 3, the control group, who were told specifically not to use their hands, just to look.
And what were they learning? Was it the heart again?
It was the harder game, yeah. A digital lesson this time, but interestingly, it was adapted from a paper lesson used in an earlier study. That's useful for comparing across formats.
Okay, and the lesson itself, text and diagrams.
Yep, text explaining things and illustrations of the heart with numbers and arrows linking back to the text. So it's clear what text went with which part of the picture.
Good setup.
Yeah.
So how exactly were the pointing group told to point? What were the instructions?
They gave them a few options, actually. They could use one or both hands to point, to link the text to the diagram bits. They could, leave a finger resting on the illustration while reading the related text.
Kind of like an anchor.
Yeah, exactly, like keeping their place visually. They even said they could use their fingers like pins on a map, just to mark important spots. The main idea was maintaining contact, directing attention, but not necessarily moving along the lines.
Okay, so a more static kind of touching. What about the tracing group?
Similar instructions about pointing initially to connect text and image. But critically, they were also explicitly told to trace along the elements in the picture as they were described.
Ah, so follow the lines.
Exactly. Move their finger along the structures, the pathways, almost like using a marker or drawing it.
So that's the key difference. Active movement along the shapes for tracing versus more holding or directing attention for pointing. And the control group, you said they had specific instructions too.
Yes, and this is really important for interpreting the results. They weren't just told, don't use your hands. They were told, keep your hands still, but really focus on looking carefully at the illustrations. Actively try to make those connections between text and picture using the numbers and arrows.
So they were still trying to learn actively, just without touch.
Precisely. They called it a fair control group design. It means any differences found are more likely due to the hands aspect, not just because one group was paying attention and the other wasn't.
That makes a huge difference in how you read the results. Okay, so everyone learns using their method. How did they measure what stuck?
They used 3 different tests.
Mm-hmm.
An identification test, basically, labeling parts of the heart.
Okay.
A terminology test, filling in blanks in sentences with the right terms.
Mm-hmm.
And a comprehension test, checking if they actually understood how the heart works. So different levels of understanding.
And the eye tracking. What were they looking for there?
They tracked several key things. How long people looked at the text versus the illustration's fixation duration, how quickly their eyes jumped to an illustration after reading about it, time to first fixation.
Right.
And how often they switched their gaze back and forth between the text and the illustration's transitions. These all give clues about visual attention and how actively they're linking the information.
Makes sense. And cognitive load. How did they measure that feeling of effort?
They used standard questionnaires. After the learning session, students rated how much mental effort they felt they put in. This gave a sense of both intrinsic load, how hard the material felt, and extraneous load, how much effort the learning method seemed to add.
Okay, a really thorough setup. Learning outcomes, eye movements, perceived effort across pointing, tracing, and no-touch groups. So, the moment of truth. What did they find? What were the key results?
Okay, so let's start with learning performance. This was really interesting. The pointing group actually did significantly better than the tracing group on both terminology and comprehension.
Wow, better than tracing, not just better than no hands.
Better than tracing. That's a huge finding. It suggests how you use your hands really matters. And the pointing group also did significantly better than the no-touch group on comprehension.
Okay, so pointing beat no touch for understanding.
Right. But here's the other surprising part. There was no significant difference between the tracing group and the no-touch group on terminology or comprehension.
Seriously, so tracing didn't really help compared to just looking carefully.
In this study, for those measures, nope. Pointing was the clear winner for learning outcomes.
That really goes against the grain of some earlier findings, doesn't it? What about the visual attention data? Did that explain anything?
It provided some really important clues, yeah. The pointing group, they spent longer looking at the illustrations, they look at them more quickly after reading the text, and they switched their gaze back and forth between text and illustrations more often than the no-touch group.
Okay, so all signs pointing towards better focus and more active linking for the pointers.
Exactly. It really backs up that attention-directing idea for pointing. They were clearly engaging more effectively with the visuals.
And the tracing group's eye movements, how did they compare?
This is where it gets even more interesting. The tracing group did not show those same significant differences compared to the no-touch group for how long they looked at illustrations or how quickly they looked at them.
Huh.
But they did switch back and forth between text and illustrations significantly more often.
More transitions, like the pointing group, but without the better performance.
Precisely. Which raises a big question.
Mm-hmm.
Were those extra eye movements in the tracing group actually helping them learn, or were they just kind of a side effect of coordinating their hand movements with their eyes?
Right, maybe just tracking their finger rather than processing information.
It's possible. The lack of a learning boost suggests those extra transitions weren't necessarily productive cognitive work.
That's a really critical distinction. Okay, what about cognitive load? Did pointing feel easier than tracing?
Well, overall, there weren't huge differences in the total reported mental effort between the groups. But there was one key finding here, too. The pointing group reported significantly lower extraneous cognitive load than the tracing group.
Lower extraneous load, so the pointing method itself felt less mentally demanding than the tracing method.
That's what it suggests, yeah. It implies that the act of tracing, maybe the coordination involved, might actually add some unnecessary mental clutter or effort compared to the simpler act of just pointing.
Okay, let's piece this together. Pointing leads to better terminology and comprehension scores than tracing. Pointing also beats no touch for comprehension. Tracing doesn't significantly beat no touch.
Right.
Pointing improves visual attention focus and active linking between text and image. Tracing increases eye movements back and forth, but maybe not productively. And pointing feels less extraneously demanding than tracing.
You've got it. That's the core picture from this study.
So when we think back to those theories, this seems to really lean towards that attention directing function, especially for pointing, doesn't it?
It really does. The eye tracking data for the pointing group aligns beautifully with that idea. They look longer, faster, and switch more, and they learn better. It's like pointing is a very efficient way to manage your focus.
And what about the other theories? Cognitive load reduction, multimodal memory.
Well, the cognitive load findings were mixed, right? Pointing seemed to lower extraneous load compared to tracing, but there wasn't an overall reduction compared to no touch. So it challenges the idea that just any hand movement automatically reduces load.
Okay.
And the multimodal memory idea that predicted tracing might especially help with recalling terms because of the motor action. But here, the pointing group did better on terminology. So that specific prediction wasn't strongly supported in this context.
So for you listening, the big message here seems to be, maybe don't assume tracing is automatically the best way to use your hands. Pointing might actually be a more effective way to focus your brain, at least for this kind of learning material.
That's a key takeaway. This study really prompts a rethink. It suggests the simpler act of pointing might be more powerful, maybe because it directs attention without adding the potential cognitive cost or coordination demands of tracing.
Were there any caveats or limitations the researchers mentioned we should keep in mind?
Yeah, a few important ones. They mentioned that their fair control group, the one told to look carefully,
The actively engaged ones.
that might have actually reduced the visible benefit of pointing compared to a truly passive control group. So pointing might be even more beneficial than these results show in some situations.
That's a fair point. Anything else?
They also stressed, quite rightly, that the type of learning material is probably crucial. Tracing might still be better for things requiring more physical exploration, like maybe learning a knot or understanding a 3D mechanism with a model.
Yeah, moving your finger on a flat screen is different from manipulating a real object.
Totally different. And they also brought up that point we discussed. Maybe the motor activity of tracing itself could sometimes interfere with visual processing or learning.
Because it's just more complex for the brain to manage.
Potentially. Pointing is a simpler goal-directed action. Tracing requires continuous coordination, more complex motor commands that might just use up valuable mental resources.
So where does the research go from here? What's next?
Well, they suggested exploring different types of pointing and tracing, maybe more guided tracing versus free-form tracing. Using different kinds of learning materials is key. Finding better, maybe more objective ways to measure cognitive load is important too, beyond just self-reports. And directly comparing tracing specific bits versus just pointing to those same bits in the same lesson would be really insightful.
Yeah, isolate that specific action.
Exactly. And finally, looking closer at the actual haptic feedback, the feeling of touch and pressure during pointing versus tracing. Does that play a role?
Okay, lots to still figure out, so let's wrap this up. For you, our listener, what's the main thing to take away from this deep dive?
I think the key takeaway is, yes, using your hands can help you learn, but how you use them matters. This research strongly suggests that simple pointing might be the surprisingly powerful tool, especially for learning from things like diagrams and text together.
Right.
It seems really effective at focusing your attention where it needs to be and helping you build understanding, perhaps even more so than tracing in some contexts.
So it's not about complexity. Maybe simplicity wins here sometimes. That's really fascinating. It definitely makes you think, doesn't it? How might you, listening right now, consciously use pointing more in your own learning?
Mhm.
Whether you're reading something dense, watching a video, trying to make sense of data, could just deliberately pointing at key elements actually sharpen your focus and boost your comprehension. It seems like such a small thing.
It does, but the potential impacts could be significant.
Hmm.
It really highlights how interconnected our physical actions and our cognitive processes are. Learning is complex, and we're still unpacking all the ways our bodies contribute to how our minds work.
Absolutely. And while this deep dive gives us some really practical insight into pointing, it also just underscores how much more there is to learn about learning itself, about embodied cognition.
For sure.
So we definitely encourage you to reflect on your own habits. Maybe give pointing a conscious try next time you're studying something visual, see if you notice a difference. And definitely stick around with us for future deep dives where we'll keep exploring these fascinating corners of how we learn.